Okay, so difference of squares and sum and difference of cubes here. So, right, you think this is a geometry lesson. It's not a geometry lesson, but it's an algebra topic here, and it's about factoring. And it is somewhat related to squares and cubes because if you think of a square, right, you think of something that has the same sides all the way around, right? And you think of a cube, right? What is a cube? Well, a cube is nothing other than a three-dimensional square, right? So you have something like this. Well, how is this related to this, right? Well, let's think of the squares one first, right? So if I think of squares, I think, let me change my color here. I think of a squared, something that looks like this, where a squared is some quantity, and I'm subtracting b squared from it, okay? And this could be anything, here, so let's see if I can explain this here to you. So if I had something as simple as this example here. So let's just say I have an example here where I'm saying that I have 16x squared, right, minus y to the power of 6. So in this case, right, my a is 16x squared and my b is y to the power of 6. And 6 at 6. So what this tells me, if I do the difference here, I actually can factor this by just saying that I would take a minus b, and then I'd do another parenthesis, and I would do a plus b. Okay, this is how I'd factor it. So then how would I factor it for something that actually has numbers? Well, what I like to do here is to break it down and say, well, what about this first term? This first term here can be my a squared term. So this one would read out as 16x squared, right? And my b squared would be written as y6. Okay, I'm not going to include my negative sign, just have y to the power of 6. And if my a squared is equal to this, well then a squared is nothing other than a times a, right? So if a squared is nothing other than a times a, right? So again, right, a squared I could say is a times a up here. Then, just like x times x, for example, then I could say, well, what is the square root of my 16 here? Actually, I won't use the equal sign here, but I'll use an arrow here. I'll say, well, then what is a? Well, a would be taking the square root of 16. That would be 4. And then I have x squared. The square root of x squared would be x. And then same thing for b, right? b. What is the square root of y to the power of 6? Well, how do I get to y to the power of 6? I have to half it. Okay, so half of 6 is 3. So I have y to the power of 3. So if I'm going to factor this, it's as simple as writing these two parentheses, right? So again, I can write the two parentheses. I don't have to write anything in here at first except for a minus sign here and a plus sign here. And then all I do here is put 4x here and a minus y to the power of 3 here. And then in the next one, I do the same thing. I plug the same thing in. I have 4x, and then I put y to the power of 3. And I know this is going to work out because I could distribute these, right? So here, right, what is distribution again? I'm multiplying this guy by this guy. That would give me 16x squared. And if I did 4x times y to the power of 3, that would give me 4x y to the power of 3. But then on the bottom side here, right, I do the same thing, and then I'd have minus the same quantity, so it would cancel out. And if I have minus y3 times positive y3, I would get minus y to the power of 6 because my exponents add up together. So that's the difference of squares, right? And I say it's related to squares because what are squares other than the same sides multiplied together? So if I take the square root of 16, if that's the area of some square, right, then I know that the side of that square has to be 4 on this side, and it has to be 4 on the bottom side or any other side. Oops. Okay. There we go. All right, so now on to cubes then. So cubes, scroll down here. if I have cubes, right, what do I know? Well, I have 3 dimensions here. So I have something like this, a to the power of 3 minus b to the power of 3. And this factors as follows. I have 2 sets of parentheses again this time, and it factors like this, a minus b, and then it factors as a squared in this one, a squared plus ab, and then I have plus b squared right here. So what does this look like? Well, if I have an example, such as this one right here, I have just 27, or no, it's actually not 27, if I had a to the power of 12 minus 8 m3 n3, right? Well, what do I have here, right? I have the same thing symbolically speaking, right? So that means that my a to the power of 3 is a to the power of 12. And my b to the power of 3 is going to be, and let me fix my 3 for my a here, so that 3 looks a little more like a 3. b3 would be 8 m3 n3. Okay, and then what is my a and what is my b? Well, a to the single power would simply be the cube root of 12, right? And with exponents for variables, I simply divide them by 2 for the squares, right? But for cubes, I divide it by 3. So 12 divided by 3 is 4. So I'd have a to the power of 4. Okay, and then for b, I would simply have, well, how do I get to 8? If I multiply a number 3 times, it has to be 2, right? So it has to be 2, and then if I want to get to m to the power of 3, I'd have to multiply m by itself 3 times, and then same thing for n, I'd have to do n times n times n. Oh, I forgot to draw an arrow here, okay? Anyway, so now, I think I'm going to have to, I think I need some more space here, so I'll do the actual writing out of the factors here, but here I have my parentheses here, and I know from this up here that it's going to be a minus sign here, and then I'll have a plus sign here, and I'll have a plus sign here, okay? And then I can fill them in. So what do I have? Well, I'm supposed to have a minus b, so a right here is a to the power of 4, and b is 2mn, so I have 2mn. And then what do I have in this second set of parentheses? Well, I have a, here I'll scroll up a second, a squared. So if I have a squared, then I simply have a times a, which is a to the power of 8, okay? And then it's plus a times b. Well, a times b is just 2mn times a4, so then I'm going to keep it in alphabetical order, so I'll just write simply this, right? 2a4 mn. And I don't have to write it in this order necessarily, but I like keeping it alphabetical. And then the last one, b squared. So if I have 2mn, right, and I can write this out here if I want to, right, but b squared is just 2 times 2, so that means I have 4. And then I have m times m, so that gives me m squared, and that would give me n squared here. So it's just simply dropping this in, right? 4m squared n squared. And that's it for the difference of cubes, right? And now what about the sum of cubes? Well, the sum of cubes would simply be written, I'm going to change my color here, would simply be written as a to the power of 3 plus b to the power of 3, right? That's how you'd notice it. And so then, this is right, obviously with nothing else except for the actual letters, but it would be a plus b, is its factor form, and then it'd be a squared minus, instead of plus here, a squared minus ab, and then it would be plus b squared. Okay, so then let's look at an example here. And we'll come back to how you remember which one is which, besides just writing them down on paper, at least some helpful ways to remember it. But here, my example was what I was getting confused earlier, but it's an example here where I have 27 plus x to the power of 6. Okay, well, then what do we have here? Well, I have this first one, 27, is my a to the power of 3. Again, you can write this out to make it clear, but you could just jump to what a is, right? But if I take the cube root of 27, in order to get to 27, I have to multiply 3 times 3 times 3, so that means that a must be 3. And if I have b to the power of 3, sorry, finish my b there, then I have, right, if I have x to the power of 6, this one's a simple one, right? But all I have to do here to get b is take 6 and divide it by 3, and then I have x to the power of 2, right? And then if I want to factor this, okay, I'll keep that up there, and then I can change my color here and try green. There we go. We're almost done with our examples. So I have what? I have a plus b. So if I have a plus b here, right, so here's my plus sign, and then I have a squared, and then I have a minus sign, and then I have a plus sign, and then I can close my parentheses. Actually, I forgot to put my parentheses up at the top too. So that means if I'm going to put that in there, right, a plus b, then I simply have, what, 3 here plus x squared. And then for this one, I have a squared, right? Well, my a is only 3, so that means it's 9. Okay, and then if I'm subtracting and I'm just multiplying a times b, then it would just be minus 3x squared, because I always keep the number in front, okay? And then if I say plus here and it's b squared, x squared times x squared, right? X squared times x squared is simply adding those exponents together. So I have x to the power of 4 plus x4. All right, and I didn't box my answer above either, but here, I can box my answer so you can say it's finished. And I can do the same thing with this guy up here, okay? It's jiggling like that, or right, freaking out here. Anyway, so now, right, besides just memorizing how these work, right, how do I keep track of them? Well, the difference of squares, I would just say you're going to have to just memorize, right? And it's not that hard, because you just take the square root of it, and you can see that it is the square root, because I can't take the cube root of 16, right? I can take the cube root of y to the power of 6, and I'd have y to the power of 2, but it has to be true for both terms, okay? And so then if I go back to my difference of cubes and my sum of cubes, how do I keep them straight? Well, there's this little trick, which is to remember this acronym here, which is SOAP, okay? SOAP here, and so I have S-O, and then A, and then it's P, but here, let me finish here, right? So it means, what sign do I have here? Well, I'm trying to write same here, same, okay? So you notice this negative sign is the same as this sign over here, and then this one right here is opposite sign, right? See that plus sign? And so that's opposite, right? The plus sign, okay? And then this one right here is always positive. Okay, and so you're like, well, how is that helpful? And if I look at my other one, how I wrote the other one, same thing is true, right? This one, this sign right here, if I see the sum of cubes, this sign right here, plus, is the same as this plus sign. And then this one, this negative sign, is the opposite of the original, right? See that? It's a negative. And then this last one here is always positive. So that's one way you can try to keep those straight. It might be helpful to just write those down on an index card, keep it with your list of formulas and things to remember. but that's how you can help try to keep them straight when you're factoring these. All right, and I think that covers that one, and some difference of squares and some indifference of cubes.